All right, guys, 11.4, two-way tables. You might have seen these on Khan Academy, or you might have seen them around. Um, a two-way table, this is something that comes up quite a bit on standardized tests. We look at it again in geometry, but we get the basics out of the way here in algebra. Two-way table is a frequency table, meaning it shows how often something occurs in our data set, what the frequency of it is. But we're talking about more than one, data collected from one source where they ask more than one question, basically, is how we're going to look at it. So you're asking one group of people, but you're asking more than one question. And it allows us to separate the data a little bit more. Rather than just saying, all right, I asked these 100 people, and 40 of them were sophomores, and 25 of the 100 people said they were going to a dance. Right? That does nothing for us in terms of finding specific data. So this helps us get a little more specific data. So you look at the first example here that we're going to base off of here. Two-way table, you've got one group of people that you're asking. So you're asking these students, and you're asking, do they have mobile access? Okay, mobile access, of course, being your cell phone, whatever. But they're asking two questions. The first question they're asking is, what grade are you in? Are you a freshman or sophomore? The second question they're asking is, do you have mobile access? And so when we take all of that data and we take the total, all the kids that we ask, we can separate this into four separate numbers. Okay, this 55, this is how many of the people that we surveyed, how many people that we asked were freshmen that said yes, they had access to our mobile access. That's 55 of them. 63 were sophomores that had access. Okay, and then of course 22 were the number of freshmen that didn't. 12 is the number of sophomores that didn't. So we read that by joining these two together, right, to get 55. We join these two together to get 12. So we can join them together, which is why it's called a joint frequency. So the numbers in the middle there are called joint frequencies. Okay, you see it here, joint frequencies. So all four of those are called joint frequencies. Okay, the numbers in the middle, because we are joining the two data sets to get that one number. Okay, that's why it's called a joint frequency. The sums of the rows and the columns are called marginal frequencies, and we don't have marginal frequencies on this, but if we did, what it would look like, and you'll see it later on, but it's going to look something like this, where it's basically just the totals. Okay, it's the sum or the total, and we're adding together. It's the total of those numbers. So we would have 77 there. I'm adding the 55 plus the 22. 63 plus 12, that gives me 75 there. Okay, I can do the same thing going down. This is going to give me 34. This is going to give me 118. And then there is one in the corner. And that one in the corner, I can either add this way, I can add this way. They both should give me the same thing, which is 152. So the important question is, what do those represent? Right? What do those represent? Well, this 118 here, that represents the total number of students or total number of people asked that have mobile access, 118. Right? The 34 is the total number of people asked that don't have mobile access. They asked 75 total sophomores, they asked 77 total freshmen. So that's what those marginal frequencies are telling us there. Right? And we can see it here. It's exactly what we just looked at. Okay, so you got to know the difference between a joint frequency and a marginal frequency. Marginal, the margins of your paper are the edges of your paper, right? So the marginal frequency is going to be the numbers on the edges of your two-way table. Okay, so now making a two-way table. Okay, making a two-way table, because you're just going to be, if we're looking at this problem, you're just going to be given this, right? You're just given that. You're not given the two-way table that it shows on the side there. So if we're going to make this, says you conduct a survey that asks 286 students in your freshman class whether they play a sport or musical instruments. Okay, sport or musical instrument. That's what you're asking. So one side is going to be the sport. Okay, so sport, yes or no. And the other is going to be instrument, yes or no. So we can create a two-way table out of it. Okay, and I know it has it down below, but we're going to recreate it here because that one's kind of hidden anyway. So based on the information that they're giving us, as 286 students, well, that's the total number of students, right? So 286, total number of students. Total number is always in that bottom right-hand corner, okay? It says 118 of the students play a sport. Well, I don't know of those 118 if they play an instrument or not, right? So that's the total here. That's the total that play a sport. 118 play a sport, and 64 of those, so of the 118, 64 play an instrument. So 64 play an instrument. 93 do not play a sport or an instrument. So no would be 93, which would go there. So then it's just logic to figure it out. It's adding and subtracting. Because if I want to find this one right here, the no, the yes to sport, no to instrument, I know the total is 118, so 118 minus 64, and that's going to give me 54. Right? So now if I know that, I can add straight down the 54 and the 93. I get 147. Okay, well, I can do some subtraction over here to get this marginal frequency. If I do a subtraction there, that's going to give me what, 158? Nope, 168, sorry, 168. Yep, that gives me 168 there. So then I got to do some subtraction to get over here and here. So I subtract, I'm going to get 75, and I'm going to get 139 for that. So we can fill it in just using kind of logic, adding, subtracting, we get that. Okay, but it's important that you put those numbers in the right spot the first time. All right, so moving on from joint frequency, marginal frequency, now we have the relative frequency. And this says it's a ratio, and ratio just means we're dividing. So joint relative frequency, all that means is we are taking our joint frequencies and we are dividing them by the total. Okay, we're dividing by the total number in the whole two-way table, so that bottom right-hand corner. So joint relative frequency, we're dividing by the bottom right-hand number. So we see it here. Okay, we see this. There's 680 total students in there. If we were to create those marginal frequencies, right? We create those marginal frequencies. This number right here would be 680. That's the number that we're dividing by. So you see each one of these you're dividing by 680. So you're taking each one of those and dividing by 680 to get a decimal. That's a decimal or a percent. That's telling us that 18% of the people surveyed are juniors that say yes, they're going to major in the medical field. Right? 35% are seniors that say no to the major in medical field. Okay? So those are the joint relative frequencies. If we want marginal relative frequencies, there's two ways we can do it. The book shows you one, I can show you the other. But the book just says simply add up the 0.18 and the 0.32, and we're going to get 0.5. Right? Add up 0.18 and 0.15 to get the 0.33. And that will tell us 33% of everybody surveyed, 33% is going to major in the medical field. All right, so we've got all that. The other way to do it is simply to take the marginal frequency and divide it by the total. So our marginal frequency down here would be 225. Okay, so if I take 225 and I divide it by 680, that's going to give me about 33%, which would give me that 0.33. So a couple different ways that we can find that. Make sure you understand where those numbers are coming from. They're going to ask you questions on that on the homework and the test next week. Okay, so that's relative frequencies. The last thing that we have here are conditional relative frequencies. And this is a little bit trickier because you got to look at the wording of the problem. Okay, so conditional relative frequency is now we're not dividing by the total. We're not dividing by the bottom right-hand number. We're dividing by either the row total or the column total. Okay, so if we look here, it says make a two-way table that shows the conditional relative frequencies based on the column totals. Columns are up and down. So if we're doing that, we're going to take the 0.18 divided by the 0.33. We can use the marginal relative frequency and the joint, or sorry, the joint relative frequency and the marginal relative frequency to divide to get there. The other way that we could have done that is we said this was 124 and this was 225. Right? We said this was 225 here. If I wanted to find this conditional relative frequency where I'm dividing by the column, I could take 124 divided by 225. And 124 divided by 225 is going to give me that same answer. It's going to give me that 0.55, that 55%. And what this is saying is 55% of the people that are majoring in the medical field, 55% of them are juniors. Okay, so it's you got to look at the wording of it because they're going to ask you some questions, and they're going to want this conditional. So we're going to have to just divide by a column or a row total. So let's move up here. Let's look at this. Let's say that I wanted what percent of seniors major in the medical field? What percent of seniors major in the medical field? Well, common sense, right? I bet you can figure this one out, but we've got 237 here as my row total. That's the total number of seniors. So out of those 237 seniors, 101 of them are majoring in the medical field. So I could then do 101 divided by 237. Okay, that's what we're looking at here. Watch the videos out of the book, right? Use the big ideas videos. They can help you. They can walk through these examples. They might teach it a slightly different way, which might be better for you, and that's okay. Right? But you got to make sure you know the difference between the conditional relative and then the joint relative or the marginal relative. It is different. The wording is different. You got to understand the difference between the two. Don't worry about example 5, example 6. We don't need to know that. You're not going to see questions on it. Okay, but you will see all sorts of things on two-way tables. You're gonna have to create them. You're gonna have to create or find the joint relative frequencies, conditional relative frequencies, all of it. You're gonna have to find that. So look at this again. Make sure you're taking notes, all that good stuff, so you're ready to go on 11.4.